Welcome back. So here in this video segment we shall be solving all the problems given in the third exercise, and all the problems are very simple. So in the previous video segment we have discussed these relations, right? So we spoke about the trigonometric ratios of complementary angles, and we observed that sine of 90 minus a is cos a, cos of 90 minus a is sine a, tan of 90 minus a is cot a, and so on. Now we observed that angle A and angle C were complementary angles, isn't it? So I had a right angle triangle ABC. Angle B was 90 degrees, so this is angle A plus C is 90. So therefore, angle A and C are complementary angles. So using this fact, we got these relations. So using these relations, we shall solve all the problems given in the third exercise, and they are very simple. So let's take the first problem. So the first problem states that we have to evaluate. So the first problem, first one, evaluate sine 18 degrees divided by cos 72 degrees. Right? So given a problem like this, you should be able to solve it within a minute. Now we observe that 18 plus 72 is 90. So therefore, I can write this as sine of 90 minus 72, isn't it? So 18 can be written as 90 minus 72 divided by cos 72. Right? So we know that sine of 90 minus a is cos a. So this is nothing but cos 72 degrees. So instead of a, I have 72 here. Okay? Divided by cos 72 degrees. So this is 1. Very simple problem. So the next one, we have tan 26 divided by cot 64. So again you observe that 26 plus 64 is 90 degrees. So I can write this as tan of 90 minus 64. Right? So 90 minus 64 is 26 divided by cot 64. Right? So I have tan of 90 minus a. So what is tan of 90 minus a? It is cot a. So I have cot 64 divided by cot 64 degrees, which is 1. Next, the third one. So you observe that these are all very simple problems. Right? So here, in the third problem, I have cos 48 degrees minus sine 42. So let me convert this. So here I can write cos 48 as cos of 90 minus 42 minus sine 42. Right? So here cos of 90 minus a is sine a. Right? So this is nothing but sine 42 minus sine 42, which gives me 0. So the answer is 0. Next, the fourth one. You have cosecant 31 degrees minus secant 59 degrees. Right? So without even solving, you can say that the answer is 0. How? Let me convert secant, right? So I can write this as secant 31 minus, this is nothing but secant of 90 minus 31. Right? 90 minus 31 is 59. So what do I get? I get cosecant 31 minus secant of 90 minus a is cosecant a. So I have cosecant 31 degrees, which is 0 here. Okay, so the first two you get the answer as 1, and the next two you get the answer as 0 here. Right? So moving on with the second problem. The second problem, show that the first one, what we have to do, I have tan 48 degrees, tan 23, tan 42, and tan 67. I need to show that this is 1. Okay, so again a very simple problem. So here the first thing what you need to observe is which two angles when you add becomes 90. So we observe that when I add 48 and 42 I get 90, and when I add 23 and 69 I also get 90. So the whole problem boils down to converting one of them to cot, because cot is inverse of tan, isn't it? So now let me convert this tan to cot. So how do I do that? This is nothing but tan of 90 minus 42, right? Now let me convert this. So I can write this as tan of 90 minus 67. So 23 is 90 minus 67. Then of course I have tan 42, tan 67. Now what is tan of 90 minus 42? Tan of 90 minus A is cot A. So this is cot 42. This is again cot 67, isn't it? Then I have tan 42, tan 67. Now cot 42 is nothing but 1 by tan, right? Cot 67 is 1 by tan 67. So these two can be cancelled, these two can be cancelled, so I get 1 here. Or if you want to write one more step, you can write this as tan 42, 1 by tan 67, and then I have tan 42 into tan 67. So these two will cancel and you get 1 as the answer. The second one, cos 38 into cos 52 minus sin 38 degrees into sin 52 equals 0. Okay, so again here we observe that when you add these two angles it is 90, when you add these two it is 90 here. So let me convert one of them to sine here. So I can write this as cos of 90 degrees minus 52 into cos 52 minus, so this is sine of 90 minus 52 into sine 52 degrees. So here what do I get? Cos of 90 minus A. What is cos of 90 minus A? Sine A. So I get sine 52 into cos 52 degrees minus, so this is sine of 90 minus A, which is cos A. So I have cos 52 into sine 52. So here also I have sine 52 cos 52 minus cos 52 sine 52. So this is equal to 0. So these two get cancelled, isn't it? It's like A into B. It's like 6 into 8 minus 8 into 6 is equal to 0. Right? So the answer is 0. So here we have an interesting problem. So if tan 2A equals cot A minus 18 degrees and 2A is an acute angle, I need to find the value of A. Right? So now what do? How do we proceed? So here I have tan 2A is equal to cot. So I have some LHS equals RL. So this is a very interesting problem where you have tan 2A equal to cot A plus 18 degrees and 2A is an acute angle and I need to find the value of A. So how do we proceed? Now we know that cot of 90 minus A equals tan A. So I have tan A. Instead of A I have 2A. So I can write tan A as cot of 90 minus A. So therefore tan 2A can be written as cot of 90 minus 2A equals cot of A minus 18 degrees. Now LHS equals RHS, it's been given, so therefore these two angles have to be equal, isn't it? So therefore 90 minus 2A must be equal to A minus 18 degrees. Okay, so if I take 2A to the other side and 18 to this side, I get 90 plus 18 degrees equals 3A. So 108 degrees equals 3A. So what is A? A is 108 by 3. Okay, so where do you get 36 degrees? Okay, so the value of A is 36 degrees. Okay, so here given LHS equals RHS, so what we have to do is I need to get cot here. So we know that tan A is cot of 90 minus A, so just convert tan to cot and then equate both the angles and you will get the answer. So this again is a very simple problem. I hope when you look at problem 4 you will be able to get the answer immediately, or you will be able to prove it immediately, because this problem 4 resembles problem 3, right? So I have LHS equals RHS. So what do? We convert tan to cot, or we can convert cot to tan also. So how do I convert tan to cot? Tan A is cot of 90 minus A. So tan A is cot of 90 minus A, which is equal to cot B. So these two angles can be equated because LHS equals RHS. So 90 minus A equals B, or if I take A to the other side, A plus B equals 90 degrees. So very simple problem. So let's move on to problem 5, which states that if secant 4A equals cosecant A minus 20 degrees, and if 4A is acute angle, find the value of A. Okay, so again the problem is very simple. So again here secant can be converted to cosecant. So here we know that secant A is cosecant 90 minus A. So instead of A I have 4A. So I can write this as cosecant 90 minus A is 4A equals cosecant A minus 20 degrees. So equate these two. So I have 90 minus 4A equals A minus 20 degrees. Alright, so let me take 4A to RHS and this 20 to LHS. So I get 90. So this implies I get 90 plus 20 equals 4A plus A. So I get 5A. 4A plus A is 5A equals 110. Or A equals 110 by 5. So what do I get? I get 22 degrees. So very simple problem. So if you observe problems 3, 4, 5, they are all very similar, right? Next, problem 6. So problem 6, if A, B and C are the interior angles of a triangle ABC, then we have to show that sine of B plus C by 2 is equal to cos A by 2, right? So again this is a very simple problem where we need to prove that sine of B plus C by 2 equals cos of A by 2. Now given ABC is a triangle, so I have a triangle ABC. Now when I add up all the three angles, so we know that the sum of all the angles of a triangle is equal to 180 degrees. So we know that angle A plus B plus C, so these are all angles, is equal to 180 degrees. So what do I need? I need B plus C. So I write B plus C equals, I take A to RHS, so I get 180 minus A. Next, what do I need? I need B plus C by 2 and A by 2. So let me divide by 2 on both the sides. So I can do that. The value does not change. Right? Okay. So now I get B plus C by 2 equals 180 by 2 is 90 degrees minus A by 2 is what I have. Now let me take sine on both the sides. So the value does not change. So I have sine B plus C by 2 equals sine 90 minus A by 2. So what is sine of 90 minus A? Sine of 90 minus A is cos A. So instead of A I have A by 2. So this is cos of A by 2. So therefore sine B plus C by 2 equals cos A by 2 is what we need to prove, and we have done that. Okay, so to proceed with this problem, you need to start with the fact that the sum of all the angles of a triangle is equal to 180 degrees, and then just proceed with what is being given here. I need B plus C, you have B plus C, and I need A, bring A to RHS, I need by 2, so divide both RHS and LHS by 2. I need sine, so just take sine on both the sides, and here you have sine of 90 minus a. So instead of a, I have a by 2, so I get cos a by 2. So again, a very simple problem. So you observe that all the problems given in the third exercise are very simple. So let's move on with the last problem. So I need to represent sine 67 degrees plus cos 75 degrees in terms of the trigonometric angles between 0 and 45. Right? So between 0 and 45 degrees. So what do I do? So we know that sine A can be written as cos of 90 minus A, right? So this can be written as cos of 90 minus. So how do I get 67? So 90 minus 23 gives me 67, isn't it? Plus. So again here cos, I can write 75 as 90 minus 15. Right? So 90 minus 15 gives me 75 degrees. So what is cos of 90 minus 23? What is sine? So sine of 90 minus a is cos a, so I have cos 23 plus, so here I have cos of 90 minus a, which is sine a, which is sine 15. So instead of a, I have 15, and this is the answer. So what is the question? The question is, I need to represent sine 67 plus cos 75 in terms of some trigonometric angle which is between 0 and 45 degrees. So sine and cosine has now been represented as a sine and cosine in terms of trigonometric ratios, but the angle is between 0 and 45. So I have 15 here and I have 23 here. Okay, so this completes all the problems in the third exercise, and you've observed that all the problems are very simple and very easy. Okay, so in the next video segment we shall go through all the trigonometric identities. Trigonometric identities which are very important. So we shall go through what they are, we shall prove them, and then solve all the problems given in the last exercise, that is exercise 4, in the next video segment. Okay, so do like, share and subscribe, and do not forget to press the bell icon to get notifications of further uploads, and thanks for watching.